Since the dawn of civilization, people have looked up at the night sky, mesmerized by its brilliance and the mysteries it holds. For millennia we've pondered what lies beyond our planet, striving to understand our place in the cosmos. Our endless curiosity has driven us to invent instruments that let us explore deeper into space, searching for answers to profound questions: how the universe began, what it's made of, and whether we are alone. The Hubble Space Telescope, for years, amazed us with stunning views of far-off galaxies, colorful nebulae, and the wonders of the universe, forever changing our perspective on space. Yet, Hubble could only observe invisible and ultraviolet light, leaving many of the universe's oldest mysteries hidden from view. The universe's earliest secrets, its primordial light, concealed stars, and the birthplaces of planets, are only visible in infrared, a type of light our eyes cannot see. To reveal these hidden wonders, scientists created a groundbreaking observatory, the James Webb Space Telescope, engineered to detect what Hubble could not. After years of development, Webb launched in 2021. Its enormous gold-plated mirror and vast sun shield enable it to gather the faintest, most ancient light from the farthest corners of the universe. Webb travels 1 million miles from Earth, well beyond the moon, kept icy cold by its sun shield so it can sense the faintest infrared signals. Its mission is bold: to uncover how the first stars and galaxies emerged, how planetary systems like ours develop, and even to search for evidence of life on distant exoplanets. Webb acts as a time portal, looking back over 13.5 billion years to the universe's earliest moments, capturing light that has journeyed across the ages. With its advanced infrared capabilities, Webb peers through dense cosmic dust, exposing star-forming regions and the most remote galaxies ever detected. As the cosmos expands, light from distant galaxies stretches into the infrared. Webb is designed to catch this ancient glow, opening a new era of discovery and transforming our understanding of the universe forever. Before the launch of the James Webb Space Telescope, astronomers believed they had a solid grasp of cosmic history, built on decades of careful observation and theory. The story began with the Big Bang, a cataclysmic event that set the universe in motion, followed by a long dark age filled with nothing but clouds of hydrogen and helium, the simplest elements. We expected that the first stars and galaxies would be small, simple, and slow to form, gradually lighting up the darkness over millions of years. Our models predicted a slow, bottom-up assembly, tiny protogalaxies merging over billions of years into the grand spirals and ellipticals we see today. Observations from Hubble and other powerful telescopes seem to support this view, and we fully anticipated that Webb would simply confirm what we already suspected. When it came to exoplanets, we knew they were common throughout the galaxy, but their atmospheres remained mysterious, their secrets hidden in faint, distant signals. We hoped Webb might just barely glimpse the chemistry of a few distant worlds, perhaps detecting water or carbon dioxide, but we expected only the faintest hints. In short, we launched Webb expecting confirmation of our cosmic story, not a revolution in our understanding. We thought we'd see faint, primitive galaxies and a slow, steady cosmic evolution, just as our models predicted. We hoped for a few precious clues about the atmospheres of alien worlds, maybe enough to spark new questions. The universe, we believed, would follow the rules and patterns of our carefully crafted models, behaving as we expected. But the cosmos, as it turned out, had surprises in store, phenomena we never anticipated and mysteries we hadn't even imagined. Webb's very first images shattered our expectations, revealing a universe far more complex and dynamic than we had ever dreamed. The universe was stranger, faster, and more spectacular than we'd ever imagined, full of unexpected structures and dazzling sights. Our story, it turned out, was just the first draft. Webb had opened a new chapter, and the real adventure was only beginning. Webb set out to find the universe's first galaxies, expecting faint smudges. Instead, it found bright, massive, and surprisingly mature galaxies, just 300–500 million years after the Big Bang. These weren't tiny villages, they were bustling metropolises, already well-formed and shining with billions of stars. Galaxies like Galaxies 13 and Maisie's galaxy pushed the limits of our understanding. Their complex structures appeared far earlier than theory allowed. It's like finding a full-grown tree where you expected a seedling. How did these galaxies grow so big, so fast? Our models can't explain such rapid growth. Maybe the first stars were more massive, or dark matter behaves in ways we don't yet grasp. Webb's discoveries force us to rewrite the opening chapters of cosmic history. The dawn of the universe wasn't a gentle flicker, it was a brilliant, roaring fire. Webb didn't just rewrite the story of the universe's birth, it's changing how we think galaxies grow. The old model small galaxies merged slowly into bigger ones, but Webb found massive galaxies that grew fast and alone, skipping the expected steps. Even more surprising, some of these giants stopped forming stars early. Galactic teenagers already retired. What could quench star formation so soon? Supermassive black holes may be the answer. Some are far larger than expected for their host galaxies. These black holes could blast out energy, blowing away the gas needed for new stars. This flips our understanding. Maybe black holes, not galaxies, drive cosmic evolution. To understand galaxies like the Milky Way, we must study the monsters at their hearts. Webb is revealing a universe where black holes may call the shots. The James Webb Space Telescope is revolutionizing our search for exoplanets, taking us from mere detection to the realm of detailed exploration. This leap forward is transforming our understanding of the universe. Its sophisticated instruments analyze starlight that filters through alien atmospheres, revealing their chemical makeup in unprecedented detail. This allows scientists to understand the building blocks of these distant worlds. Webb's study of the exoplanet WSP-96b delivered the most detailed exoplanet spectrum yet. Clear evidence of water vapor, clouds, and hazes. This discovery marks a significant milestone in exoplanet research. This achievement proved that Webb could reveal not just single gases but entire alien climates, offering a glimpse into the complex atmospheres of these distant worlds. Webb also detected carbon dioxide in the atmosphere of a rocky planet, LHS 475b, a first for an Earth-sized world. This finding opens new possibilities for studying planets similar to our own. While LHS 475b is too hot to support life as we know it, this milestone shows Webb's capability to study atmospheres on small rocky planets, paving the way for future discoveries. These discoveries transform exoplanets from distant dots into real, diverse worlds with unique characteristics and potential. Some of these worlds are hot Jupiters with rock clouds, showcasing the variety of planetary environments. Others may be water worlds, hinting at the possibility of oceans and perhaps even life. By decoding their atmospheres, we learn about their history, geology, and potential for life, expanding our understanding of the cosmos. Webb acts as our chemical scout, pointing us toward the most promising worlds that could harbor life. The search for biosignatures, gases like oxygen or methane, has truly begun, marking a new era in the quest for extraterrestrial life. With each discovery, Webb is bringing us closer than ever to answering the age-old question, are we alone in the universe? Webb's surprises aren't limited to distant galaxies. It's transforming our view of familiar worlds too. Its infrared eyes revealed Uranus's faint dusty rings and dynamic storms, turning a boring planet into a fascinating one. Webb's image of the Southern Ring Nebula uncovered a hidden companion star, showing how stellar partnerships shape cosmic beauty. The iconic pillars of creation, once dark towers in Hubble's view, became translucent in Webb's images, revealing hundreds of newborn stars. Webb lets us witness stars at the moment of their birth, a process once hidden from view. These discoveries prove Webb isn't just testing old theories, it's a true tool of exploration. Every observation brings the chance of something entirely new. From hidden rings to unseen stars, Webb constantly reminds us the universe is full of wonders. Its greatest gift may be the unexpected. Each new image is a cosmic postcard, keeping us on the edge of discovery. Webb is showing us that even our own solar system holds surprises. Why do Webb's discoveries matter to us? They push the boundaries of science, forcing us to rethink physics, astronomy, and chemistry. When observations break our models, we're driven to deeper understanding. Webb's findings connect directly to our origins. The elements in our bodies were forged in ancient stars. By studying the first galaxies, we trace our cosmic family tree back to its roots. The search for life is one of humanity's greatest quests, and Webb is our best tool yet. If Webb finds biosignatures, it could change our view of life, science, and ourselves forever. Even if we don't, we learn to cherish our own planet's uniqueness. Exploration is in our nature, and Webb is the pinnacle of that spirit. Its discoveries inspire wonder, connect us to the cosmos, and remind us how much there is left to learn. Webb's discoveries are reshaping how we see ourselves in the universe. For centuries, we've learned we're not the center of everything. Now, Webb shows us a universe that's faster, more complex, and more mysterious than we imagined. Our tidy models have been upended, reminding us we're still beginners in cosmic understanding. The universe isn't obligated to fit our expectations, it's grander and stranger than we dreamed, yet it's empowering. We built a machine that looks back to the dawn of time. We're not just observers, we're participants in the quest for knowledge. We are the universe trying to understand itself. Webb's images make our story feel like an unfolding epic, full of surprises. We're smaller than we thought, but our curiosity is more powerful than ever.